Okay, so we are planning out how we want to lay test 1 out. Okay? So Monday we'll be finished with material. So what I was thinking, and we can adjust if we need to, but what I was thinking is that Wednesday the 15th, we would go ahead and do the test review. So what that will be is I will post a practice test on Hawks. Okay? It's 0 points, so you just use it to study. It's just a study tool. But I'll post a practice test on Hawks, and then on test review day, we'll just work through all the problems that we got on the practice test there. I'll give you an idea of what kind of problems from each section to expect on the test. Okay. And then Friday, is it the 17th? I was thinking we would have a day where you could, if you wanted to, you can come to class and get Hawks help, and we'll just work on Hawks that day during our class time. I'll be here to help. Or you can work together in here, use the room, whatever on that day. So that would put test 1 on Monday the 20th. Okay. So how's that sounding? Got other ideas? I know we got some with fall activities going on and stuff. I know we got some people missing on Fridays. Why I think Wednesday would be the better day for the review, but I'll record it too. So any thoughts about switching anything around? Anything major going on the 20th that I'm not thinking about, that a bunch of you will be gone and it'll be inconvenient to miss the test that day or anything? Okay. I mean, it doesn't really matter to me which day we do it. So. Okay, so we're looking pretty good on that. That's what we'll say then. Okay, so we'll schedule test 1 for Monday the 20th, and then we'll do a review on the 15th, so that'll give you several days. It'll be from Wednesday to Monday. Get ready there. Okay. And like I said, if you know you've got to miss that Wednesday or something, I will record our test review too. So okay. I won't record that Friday because we're just working on Hawks problems, so there won't be anything to pick up unless it's your particular Hawks. So the rest of those will be recorded though. Okay. So that is good with me. If it's good with you. So okay, so we've got one section to look at today. It's not a long section, so kind of get to slow down a little bit here. We're not going to have any multiple section days or anything for a good while that I remember. This Friday. Yeah. Okay. All right. So moving to a new chapter. We finished chapter 2. We're moving into chapter 3, and our topic that we're looking at in chapter 3 is what we would call logic. Okay, so we did sets in chapter 2. We'll look at logic in chapter 3. And you'll probably notice as we go through chapter 3, there's a fair bit of similarity between some of the stuff we did in chapter 2 to some of the stuff we'll see in chapter 3. But there are a lot of differences. Okay, a lot of differences. So in 3.1, we're just going to set up what we mean when we talk about logical statements or mathematical statements, and then toward the end we do have this thing called negation we're going to look at. Okay, but for the most part, and we're going to be just making what we would call logical statements. Okay. Come on in. So if we're just talking English, okay, then usually statements, we just basically mean a sentence that ends with a period, right? If we're just talking English. But we have a lot of things in just our typical English language that would not qualify as a logical statement. We have things like figures of speech, all kinds of different weird things that we use in English when we're communicating with each other that are not necessarily logical statements. In math, okay, we are going to use English, okay, since that's the language we're all supposed to be able to speak in here. We're going to do statements in English. We'll change them into symbols later. Okay? But we're going to put some restrictions on things that we count as statements. Okay? So if we're going to talk about a mathematical statement or a logical statement, we were being a little restrictive here. Okay? It's not just any sentence we can make. We do still want a complete sentence. Okay? We're going to bend the rules of grammar a little bit in some places. So some things might seem grammatically strange, but we still do want a complete sentence here, and we want a sentence that makes some type of statement that we can figure out if that statement is either true or false. Okay? So we need some claim that we can say is either true or false, and then we get this little tag on here that says, but not both at the same time. Okay? So we'll kind of get an idea of things to exclude here in a second. Now, we're not necessarily concerned about whether the statement is true at the moment, okay, or if the statement is false. When we're checking to see if something's a statement, we're just checking to see if it has to be one or the other. Okay? So like if I said my shoes are gray, that would be a statement by this definition, okay, because either that's true or false. If I said my shoes are blue, I know you can't see my shoes, okay, that's still a statement even though they're not blue, okay, because it's either true or false. We got some weird things like that we kind of have to think about with these, but we'll work through them, okay? So here are a couple of statements. Our notation, the way we write down that we're talking about a logical statement, usually we use a lowercase letter and then a colon, okay, to declare the statement. Our textbook uses A, B, and C, or P and Q a lot, is our lowercase letters they like. So here are two statements. So here we would say statement A says the car is blue and the cat is black. So that's a logical statement because, and it's missing a period. Okay, that's just a typo there. Missing a period there. That is a logical statement because this thing is either true or false. And we don't care which one it is right now. But it does either have to be true or false. And it can't be both at the same time. B says the first even number is 2. So that is a logical or a mathematical statement because it's either true or false. It doesn't matter if we know if that's true or not, it's just that it has to be true or false. So what type of English statements would not be mathematical statements? Well, one we got to give a name to. You've probably heard this before, but one we have to give a name to, and that's a paradox. As if we have a sentence that contradicts itself. So the thing that happens with a paradox is when you start trying to think about a little bit later, when you start trying to think about if this statement is actually true or false, you kind of end up going in a circle. Okay? So a paradox would be a statement like, everything I say is a lie. So if that statement's true, that means the thing I just said is a lie, which means the thing I just said was true, which means the thing I just said is a lie. And you just get in a circle there. Okay? And you can't ever nail down a truth value. Okay? That would be a paradox. Okay? The other big example of statements that are not mathematical statements or logical statements would be opinions. Okay? I said 7 is the best number. Okay? That doesn't have a truth value. Okay? It's just an opinion. So you can't say for sure it's true or it's false. That would not be a mathematical statement. So let's look at a few statements and see if we can decide if they're mathematical statements or logical statements or not. Okay. All right, so A says it is raining outside. What do you think, mathematical statement or not? Does it have a truth value? Yes, it is a mathematical statement. It has to be either true or false. We don't care which one it is right now. If we look outside, I don't think it's raining. Okay? So I think at the moment it would be false, but we're not concerned about that right now. Okay? It has to be one or the other, so it is a mathematical statement. What about B? We've got beaches are the most beautiful place to vacation. No, why not? Yeah, we've got an opinion in there. Okay, so that's subjective. Depends on who you're talking to, whether or not they would agree with that or not. So. What about C? It says today is Monday. It is a mathematical statement. Don't get tripped up that today's not Monday. Okay? It's okay for it to be false. But that is a mathematical statement. What about D? It says today is Monday and tomorrow is Friday. That one is too. That one's a little weird to think through, okay, because if you start actually trying to decide if it's true or false, okay, so you'd say today's not Monday, so this thing's not true. And even if you're on a Monday, tomorrow's not going to be Friday, so it's going to be false no matter what day of the week it is, but that's okay. Okay? All we care about is that it is either true or false. And then what about E? I lie all the time. No, because we remember what we called it? Paradox. It's a paradox. Okay? So B here is an opinion, so it's not. And then E is not because it's a paradox. Okay? The others are mathematical statements. Okay? Questions on any of those? Are you good with them? Okay. Let's this one's a little tricky. Okay? This one says write down 2 statements of your own, one that is always true, one that is always false. This again is one of those things that should be easy because you've got like an infinite number of choices of what statement to write down, but when you actually start trying to think about one, our brains make it hard. So let's just look at the first one. Can we think of a statement that's always true? Anybody, you don't have to. I'll be happy if we come up with 2 statements collectively that fit these. So. Think of anything that's always true? All right. So there you have to be a little careful. I agree with the sentiment there, though. I mean, you do have to be a little careful because you could be nitpicky and say hard is subjective. So, but I agree with the idea there. Okay. You might think anything else? Halloween's October 31st. Okay, that's pretty good. Anybody think of one that's always false? That one to me is harder sometimes. Well, see, that wouldn't be, that's a opinion, right? Yeah, no, that's all right, yeah. So you're thinking of something that's not a mathematical statement. Right? We're trying to find a mathematical statement that's false. So we saw one that was always false already back on our last examples. That was D, because it says today's Monday and tomorrow is Friday. So any day that's not Monday, it's false. Okay? And then if we check on Monday, tomorrow would not be Friday if today was Monday, so it would still be false on Mondays as well. So that one would always be false. Those are a little tricky for my brain to come up with. You think any other ones? Yeah, because yeah, you could work that. You could work that, and if you're thinking about it nighttime, you have nighttime, the sun's not shining. So. Okay, all right, I'll go with that. All right, so lots of choices there, but again, that's just one of those things, at least for my brain, it's hard to pin one down to come up with an example when you're on the spot. Okay, so once we have a statement, okay, the first thing that we want to talk about doing with that statement is coming up with what we call its negation. Okay, or sometimes you'll see it called its denial, and the denial of a statement. So the idea is that a statement's negation has the opposite truth value of the original statement. So if the statement is true, the negation should be false. If the statement's false, the negation should be true. And the part that can make it a little tricky sometimes is that we've got to make sure that the two statements are always opposite truth values. They can't have any overlap. So when we're writing a negation, we've got some notation we use. Here's this symbol again, but remember we're looking into a different branch of mathematics when we're talking about logic, so symbols have different meanings here. We're back to the squiggle. Okay. But here's when we see a squiggle dealing with logic, okay, squiggle means the negation, or you can read it as the not symbol. Okay. So if we've got statement E here, it says 5 is a prime number. That's a true statement. So the way we could come up with the negation is we could say 5 is not a prime number. And that one will always be false. So lots of times, especially if we're just dealing with simple, one-part statements, we can throw a not in there somewhere and we get the negation. That's not always the case, but with these simple statements, it works most of the time. Okay. Something to think about here. So here's our negation of E. It says 5 is not a prime number. What if we wanted the negation of that? So we're trying to negate this statement, that 5 is not a prime number. That works, okay? So we could go back and we could say, if we do the double negation, we just get back to where we started from for E. So one way to negate 5 is not a prime number is to take the not out and say 5 is a prime number. Okay, that's perfectly valid. Okay, so if you double negate something, you can end back up where you started. But There's another way we can do it that's also perfectly valid that's weird, so that's the one I want us to. Now we don't have to go that far. All right, so just think about our tool where we just throw a not in to negate something. So here we said 5 is a prime number. To negate that, we say 5 is not a prime number. How could we use not to negate this in here? Say it one more time. That's exactly right. So in grammar class, your teacher would be mad if you said that, but as far as logic, it's technically okay. We could say 5 is not a prime number. Okay. So don't write that in a paper or anything. Okay, but having a double negative is okay in logic statements. Okay. This is better. Okay. It's easier to understand if we just said 5 is a prime number. But there's nothing wrong with saying 5 is not a prime number. Okay. Logically, that works. Logically, that works. So just a weird situation that we can talk about there. So if we just have a simple little statement, lots of times we can just throw in not and get the negation. It's not always the case. Sometimes we have a little bit more complicated statements. And those are statements that use these things we call quantifiers. So there we're talking about a quantity of something. Okay, so we might have a statement that says all something or some something. Okay? And we got those quantifiers there. So when we're negating a statement that has one of these quantifiers, we have to be a little more careful about our negation. So like if we had a statement that was using all, like if I said all the students in this room attend JSU, and I wanted to negate that, you have to be a little more careful than just throwing a not in there. There's several ways we could do that on that one. So think about what would the logical opposite be of saying all the students in this room attend JSU. We could say not all the students in here attend JSU. Or we could say some of the students in here do not attend JSU. Or we could say there's at least one student in here that does not attend JSU. All those would be logical opposites. What's tempting on that one, if we say all the students in here attend JSU, it's tempting to think that the negation would be that none of the students in here attend JSU. But that's too far. That's too far. We don't have to have none. We just need at least one. So it gets a little trickier when you got the quantifiers involved. Got a little table there to help. Okay. So let's see if we can negate some statements here. So let's look at statement A. It says Melanie is wearing a red raincoat. So how could we negate that? Don't overthink it. Melanie is not wearing a red raincoat. I like it. Okay, didn't have to think too hard about that. We just threw a not in there. And we can just say Melanie is not wearing a red raincoat. So we'll just put not in here. There's our negation. Okay. Yeah. What about B? It says the door is not closed. Okay, so we could say the door is closed. So we could get rid of not and say the door is closed. Okay. What's the weird way we could do it? Yeah, we could say the door is not closed. Okay. But the door is closed is better. Okay. C, we've got a quantifier, so we might have to flip back and look at our table. Our quantifier here says none. So C says none of the tourists brought raincoats. So what would the negation of that be? Let's say it one more time. Some of the tourists brought raincoats. That would work. Okay? And there's other ways you could do it too. Okay? If we go back and look at our table here, if we said none, well, you don't have to go all the way to all. Okay? You can just say there's at least one that didn't bring, or there's some didn't bring. Okay? Okay. And then D here says I run less than Kara. How could we negate that? Had to be, so you could say more, but that's not quite enough if you're going to do it that way, because that leaves out one possibility. The opposite of less than is not greater than, it's greater than or equal to. Yeah, or equal to. So you could say, I run the same or more than Kara. Okay. So that would be fine. We've got kind of a cheaper way, or a little easier way we could negate that one. Instead of saying I run less than Kara, what could we say? We could just say I do not run less than Kara. That works too. So either we can just throw the not in there and say I do not run less than Kara, or if we're going to think about the opposite of less than, you have to include that the same, the equal to part there. So we could say I run the same or more than Kara. Have to be a little careful with that one. Questions on it? Yes, you got a question back there? Or are you just stretching? Okay, sorry. Okay. Let's do one more with the quantifier here. This one says some of the students completed their assignments. What would the opposite, or what would the negation of that be? None of, yeah, that would be good. We could do it that way. We could say none of the students completed their assignments. That would work. Okay. And let's see if they got any other suggestions on our little table. Let's look. I think that might be the only one. Yeah, none. All right. Okay, so that works there. Okay. All right. The next thing we need to think about with these logic statements, okay, is combining statements together. Okay. So we've seen a couple as we look through the examples, but we can take these simple mathematical statements and join them together. And we've got a few keywords we can use to do that. Okay. So really we've got three we're going to talk about today. Okay. So our key connective words here are and, or, and then the last one implies. Okay. Sadly, there's lots of different ways to say implies. So for implies, usually the way we're going to see it is going to say if something, then something else. Okay. That's usually how our implication is going to be set up, but there's a bunch of different ways those can be worded, unfortunately. The other two, and or, are pretty straightforward. We'll say statement 1 and statement 2, or statement 3 or statement 4. Okay. With the implies, we would say if statement 1, then statement 2. Whatever those are. Okay. We have different symbols that we can use for these connectors. Okay. If we're using and, our symbol we use looks like a capital A without the bar, or an upside down V. And If we're using or, it's just flipped the other way around, so it's like a capital V, or. And then implies, no matter how we word it, our symbol we use for it is kind of strange looking if you've never seen it before. It's like an arrow with a double bar. So it's kind of like we take an equal sign and then put an arrow on the end of it. That's implies. Let me write implies. Or if then, you can say it's if then. And these might, as you go through this, you might pick up these are a little bit similar. When we were dealing with sets, we had intersection, and it was like an upside down U. And we had union, that was like a U. So just instead of them being rounded, we've got pointy symbols here. So and's kind of like intersection, or is kind of like union. And we did not have anything similar to implies with sets. So if we want to put two statements together, sorry, I kind of wrote in the way. Here, like if we want to join our logical statements with and, okay, we could write it like this. So this is like we had two statements, P and then statement Q. We could say P and Q. And remember, I told you mathematicians are lazy, so this is a way for us to not have to write as much down. Instead of having to write a big long statement, we could write P or Q. And then the other one here, if we put this one in here, we would read that one, P implies Q, or the way most of ours are going to be written would say if P, then Q. All right, let's see if we can make a compound statement here. So this one gives us statement A is snow is falling. Statement B is the sun is shining, and we want to symbolically make statement C. Statement C says snow is falling and the sun is shining. Okay. So if we're trying to do that statement C in symbols, snow is falling, that would be statement A. Sun is shining, that's statement B. And then what's our symbol for and? The upside down V. So here we would say A, and that would be our symbolic compound statement there. Before we do an or, there's something to think about. And that's that in English, when we say the word or, sometimes we mean one thing, sometimes we mean something else. So if someone asks you, what do you want for dinner? Do you want hamburgers or spaghetti? And what they're asking is, which one of those two do you want? So your normal answer would be hamburgers, or you could say spaghetti. But there's another meaning, and sometimes people, when they're trying to be cute, you know, or clever, seem clever, they'll answer. So they have the question, what do you want for dinner? Do you want hamburgers or spaghetti? And they'll say yes. Have you ever heard anybody say something like that? So what are they saying then? They want both. They want both. So two different meanings for the word or. So one of those we call the one where we're strictly picking between two things, we call exclusive or. or if we're leaving in the possibility that you could choose both, that's what we call inclusive or. So we have exclusive or, inclusive or. When we're dealing with logic, when you see the word or, we're always going to mean inclusive or. So that means one, the other, or both. So can have both. If we ever mean exclusive or, we have ways of specifying that. Okay? If you just see or, we always mean inclusive or. All right, let's see here. Let's see if we can make an or statement. Okay. So I'm going to use symbols to make another compound statement here. Statement P says he will go to the movies tonight. Statement Q says he will stay home to give the dog a bath tonight. Okay. We want to make statement R. He will go to the movies tonight, or he will stay home to give the dog a bath tonight. Okay. So if we break it down, okay, we're trying to make statement R in symbols. So this part that says he will go to the movies tonight, that's P. This part that says he'll stay home to give the dog a bath tonight, that's Q. And then we need to combine that with or, which is like a capital V. So our compound statement here would be P or Q. So this means he will go to the movies tonight, or he'll stay home and give the dog a bath tonight. Okay. Questions on that one? You hanging in there? All right. I think we've already talked about implication a little bit. I guess I jumped the gun on that. So let's look at it a little more closely here. Again, unfortunately, there's a lot of ways we can word these. The main one, though, when we're dealing with the implication, is we'll read it if A, then B. Okay? So if we have this notation here, and with a double lined arrow, we would read that if A, then B most of the time. And again, you could say A implies B. That's true also. There are lots of other ways to say it too, but our go-to, okay, is going to be if the first statement, then the second statement. Okay. So if we want to make one of these, okay, I'm going to turn this one into symbols. Okay, statement S says the water temperature on Saturday is below 76.2 degrees. Statement T says you're allowed to wear a wetsuit in the triathlon. We want to turn that into statement Q. It says if the water temperature on Saturday is below 76.2 degrees, then you are allowed to wear a wetsuit in the triathlon. So this first part, the water temperature part, is S. The second part, that you are allowed to wear a wetsuit part, is T. And we want to put those together with this if-then relationship. So what we want our symbols to say is if S, then T. So the way we write that down is with the double-lined arrow here, the implies symbol. So when we read this, we'll say if S, then T. Okay? If whatever's on the left, then whatever's on the right. Okay? Sounds a little weirder because you don't just have one word that turns into a symbol like with and or. Okay. Another name for these implication relationships are conditional statements. So you say if the condition, then the result. All right. Question on that one? Almost done today. It's not a long section. Let's make a few more statements here. Some practice in. So there's our symbols again. We covered them all. So and to me, the way I remember these, and looks like an A without the bar across the middle. And then I know or goes the opposite direction. And then the other two, you just really have to remember. Squiggles are negation. Then we got the double-lined arrow for implies. All right, so make a few statements. We got three basic statements or three simple statements we're working with. Statement A is I'm hungry. Statement B is I'm tired. Statement C is I'm in college. Okay. So we want to symbolically recreate these other three statements. So on number one, we're trying to make a statement that says I'm hungry and tired. So how could we do that? I'm hungry is A. And then we need and, so that's that symbol. And then B, that's all. Okay, I know the wording's not exactly the same. Like if we exactly said that, it would be I'm hungry and I am tired. That's okay, that's the same meaning. Okay. So it doesn't have to match up exactly word for word, as long as you got the same meaning. That's just an English thing. We could reword the English on statement one. That's not a big deal. Okay. What about two? It says I'm hungry or I'm in college. Well, we don't have the tired part in there. It would just be, oh, V. Yeah, you're right. Sorry, I misheard. So A, the V symbol for or, and then statement C for I'm in college. Okay. And then three, we gotta work just a little bit harder because the first part's I'm tired, so that's statement B. It's and, yeah. Yeah, so on the last one, it says not in college or I'm not in college. So we have to use the squiggle, right? We have to use the negation. We have to negate statement C. So there we would have B and squiggle C, okay? Or B and the negation of C. Okay, so those negations can be thrown in there too. Okay. Questions on any of those? They're not bad. All right, well, enjoyed the little bit of a short day. Okay. See you Friday. If you have any questions, come see me. If you didn't sign the sign-in sheet, make sure you get on there. I'll track it down and put it on the front table up here. Thank you.